Okay, so I'm going to do a mic check to make sure you guys can hear me, and looks like you can. So this is going to finish off what we did in pre-calc yesterday. And you guys had that fun lesson about equations of ellipses. And I honestly don't remember how far I got in your notes. I'm assuming we did this. So we're going to talk about where the ellipse has y-axis, the major axis. And you kind of see the line of symmetry here is with the y-axis. It's splitting the egg long ways on the y-axis. Everything stays the center. We're still focused, we're still centered on the origin, so it's 0, 0. Now, your foci move with the major axis, and you can kind of look at the graph and you can see here that you have a focus at 0, C, and again, remember, foci is a C, that's where you get that letter from, and you get 0, negative C. Your major vertices, you still have your major vertices, and that should say major, because they are major. They're on the same line as your focus and your center, but they're 0A and 0, negative A. They have minor vertices over here. They're on the x-axis this time because it's the minor axis. Negative B0 and B0. The form stays exactly the same actually, except for the location of A. Now this is a major axis. It's all about the major axis. The form is actually x squared over b squared plus y squared over a squared equals 1. So it changed a little bit. You know, when I taught you in class yesterday, it was x squared over a squared plus y squared over b squared. It changes just a little bit. Let me get that out of the way. The reason it does this is because A is associated with the major axis. It's associated with the major axis, and Y is the major axis, so it moves a little bit. The other thing you had to know was kind of that Pythagorean theorem idea, and we talked about that. If you do a little Pythagorean theorem on this right triangle, you get that b squared is a squared minus c squared. So that still holds. So it's not actually that much different. It's really not. Now we're going to do an analyzing, and if I go too fast for you kids, you hit a pause button. That's what you do. You hit a pause button. In fact, you might pause and then kind of rewatch and hear me talk. But I don't have 20 minutes right now. So you get what you get. So here's our analyze. Now, the forms you're talking about, I've got it right up here. Notice you're supposed to equal a 1, and you don't. So the easy way to fix that is to divide everything by 9, because you are supposed to equal 1. And if you divide out the 9, whoops, that's not a 9. 9 over 9 is 1, isn't it? If you divide out a 9, you get that one that you were searching for. So now it looks like the form, and you can kind of tell that this is bigger, bigger number. We have a major axis is the y-axis. So it's kind of in the form of x squared over b squared plus y squared over a squared equals 1. So we can get 2 letters of the alphabet really simple here. B squared would be 1 because they line up, which means that b is 1. It's actually plus or minus 1. A squared lines up nicely with 9, so a is plus or minus 3. And the only other letter of the alphabet we're missing is C. So we're going to plug in what we know. We're going to plug into b squared equals a squared minus c squared. So 1 is 3 squared minus c squared. This is 9. 1 minus 9 is negative 8. So negative 8 equals a negative c squared. You're going to divide out your negative, and you get that c squared is 8. Now, in the world of mathematics, we're supposed to say that that's 2 roots of 2. Simplify the radicals. I think we have everything we need to graph right now. We figured out our vertices here. A is plus or minus 3. So this tells me I have vertices at, and it's about the y-axis here, 0, 3, and 0, -3. So up 3, put a point, down 3, put a point. Now C gives you your foci. That's what C gives you. And they're going to be along the same major axis. So your foci are at 0, 2 roots of 2, and 0, -2 roots of 2. Now we're going to have to approximate 2 roots of 2 just so we can graph it. 2 roots of 2 is really close to 2.83. Really close. So I'm just going to get really close to those 3's, and I'm going to say that's where my focus is. What you got? Anyway. And then we're going to look at B. We also have vertices here because this B is plus or minus 1. Now, since that's the minor axis here, in this case the x-axis, we have vertices at 1, 0 and -1, 0. So we just put that there and there. And I know it's really, really small because I didn't plot out my work before I started doing things. But there's my ellipse. And, pause this and look at it and study it all you want. You've got all the time you need. So here we're given some information and we're asked to find an equation and graph it. Find it and graph it. So that's what we'll do. We have a focus at 0, 2. So that's up 2. There's a focus. Now, focuses are symmetrical. There's one focus at 0, 2. By symmetry, there is another focus at 0, -2. Symmetry because we're centered around the origin here. So we get to use little cheating techniques like that. So there's another focus down here because we have 2 of them. That's what we call them foci. We have vertices at 0, -3 and 0, 3. That's pretty simple. There's my vertices. So we're going to be drawing around. And this gives us stuff. We get the letter A from the vertices. We get the letter C from foci because foci has a C. And if we want B, we just do that little Pythagorean theorem equation. We say B squared is A squared minus C squared. So B is unknown. A is 3. That's going to be 9 when you plug it in. C is 2. That's going to be 4. And B is plus or minus the root of 5 when everything is said and done. Now, those are your other little vertices. They weren't listed. So there are some other vertices. They are going to go along the x-axis. So you're going to have the plus and minus root of 5 as your x values. And if you're on the x-axis, your y values are 0. So there's your other vertices. Now, if you go to a calculator and you type in root of 5, it'll tell you that it's about 2.23.
I'm sorry.
That's okay.
You should be getting an email from Mr. West. He's canceling the afternoon meeting.
Oh, that's my
And so this is your agenda, and he's going to email some highlights of that.
Okay, I already know the most important one. Homework is allowed.
Oh, is it?
Yes.
I'm glad you said that because I didn't know it.
Homework is permitted.
All right. Okay. Bad for y'all.
Well, I've known that. I knew that before fall break.
What?
Why do you think I started giving y'all homework? Because I already knew it was. Sorry, kids. Welcome back to high school.
What does it matter with COVID?
No, it doesn't. If you're one of those kids that gets really sick, yeah, we'll understand. But those kids are far and few between. 99% of y'all are just going to feel bad for a day. It's just the way it is.
I've been having to work so many in the 90s.
Well, you're in dual enrollment courses. That no homework rule never applied to them. Anyway, sorry, I got interrupted over here. So, oh yeah, these have to be plotted. So I'm going to go out a little bit farther than 2, There's another minor vertex. A little bit farther than -2. So there's my other little vertices. And that is everything you need to draw an ellipse. You know, you really don't even need the focuses to draw the ellipse. It's just they're supposed to be there. They really are. They are supposed to be there. We never did write an equation, did we? So let's do that. We decided that b was the root of 5. So we're going to take that root of 5 and we're going to square it. We decided that a was 3, right? So we got to take that 3 and square it, and it has to equal 1. That's just something that has to be there. It has to equal 1. And you know full well if you square a square root of 5, you get 5. If you don't, you really need to go talk to PK and get out of this class. That's just honest to God truth. Go talk to PK. All right. The rest of your notes are about what you do if the ellipse is not centered at the origin. I got a little sad face there. It actually doesn't make it that much harder. It really does not. Most of the stuff you figure out by graphing and realizing that everything is about a relationship to the center. Well, we use forms here. You've done circles in Algebra 2. You've done transformations, and we like using the letters H and K. In fact, I think we used them with parabolas the other day. We did. We used those H and Ks. So if the x-axis is major, well, we just take away h from x and we square it. It's still over a squared. We take away k from y because h and k is the center. And we still put it over b squared, and it still equals 1. And it turns out that b squared is still a squared minus c squared. That's not going to change. That's just true for both of them. When y-axis is major, the only thing that changes is the location of a and b. B squared is under s. And a squared is under y. Still equal to 1. Now, when I graph these, you'll understand, hopefully, that because you're not centered around the origin, you have to do a little more thought. It's about distance when you start applying concepts of symmetry. So we'll do 2 of these. Maybe 3 of them. And I need to stop and get this converted so I can get out of school. So find an equation for the ellipse with a center at 2, -3, one focus at 3, -3, and a vertex at 5, -3, and then graph this thing by hand. So I'm just going to go ahead and start graphing what they tell me to do. It is centered at 2, -3. There is the center. Everything is about the center. And in fact, I can start writing parts of the equation. I can fill in x minus 2 squared plus y plus 3 squared, and it will equal 1. I got to figure out what b squared and a squared are. I have a focus at 3, -3. So to the right 3 and fall 3. There's my focus. Okay? Look and see how far apart they are. Okay? I'll make a little note down here below. The distance from the center, 2, -3, there's a center, to the focus, 3, -3, is 1. And if you lay these things out, and I wish I would have laid them out better, if I would have drawn the focus first like this, put the center here, I could kind of see that I'm just subtracting 1. So the other focus is found by subtracting 1 from x. There's your other focus, because it has to be 1 unit away. The other focus is at 1, -3. And maybe you can see that better with a graph. That's one of the points of graphing. 1 unit to the right, the other guy's got to be 1 unit to the left. There's your other focus. But that's kind of how you view it without looking at a graph. So back up here to the text, we have a vertex at 5, -3. So 4, 5, still in the same spot. And we need to think about not necessarily symmetry. The other vertex is not 5 units to the left, back here at -5. It's not. It's about distance to center. We are symmetrical with the center. And that's the big thing, symmetry with center. So I'm going to start talking about the center and this vertex. Now we have a vertex at 5, -3. We have a center at 2, -3. And look what's happening. You're just subtracting 3 on the x component. So subtract 3 again. The other vertex is at -1, -3. Things have to have symmetry. I'm doing a freehand drawing, but I'm trying to keep the points roughly symmetrical to each other. There's your 2 foci, same distance to center. There's your 2 vertices, same distance to center. Now, what I notice here is that this is my major axis. That's where 4 points are. There's only 6 points when we draw. That's where 4 of them, that's where most of them are. And that's parallel to the x-axis. This is x-axis major. That's what it is, x-axis major. So that tells me that a squared is going to be here and b squared is going to be there. Now we get a from the major vertices. That's where we get a. And it is the distance from center. It's the distance from the center. And when we did this, we found out that we had a distance of 3, right? Let me make that a note down here. The distance is 3. So this is going to become x minus 2 squared over 3 squared, which we'll figure out in a second. And I still got to figure out what b is. Well, that's what a formula is for. That's all it's for. So I decided that a was 3. If you look down here where we start talking about the focus, you can figure out what c is. C is the distance to center. Well, it was 1 unit, right? You can look at your graph. It's 1 unit. C is 1. So I do a little bit of that theorem. I do b squared equals a squared minus c squared. So b squared is a, which is 3. 3 squared minus c, which I decided was 1. 3 squared minus 1 squared. And that's 8. And you simplify that to be 2 roots of 2, and it is plus or minus because we had a square. And if somebody actually asked you for the exact coordinates of the other vertices, well, you'd realize that these are minor vertices, and they are located above the center. They are. The x value doesn't change. The x value is at 2, but the y value changes. We've got to be 2 roots of 2 above. 2 roots of 2 above. So we have to say it's -3 plus 2 roots of 2. And we have to be 2 units below. So we say -3 minus 2 roots of 2. Now, that doesn't help you much for graphing purposes. It really doesn't. 2 roots of 2 is going to be 2.83, roughly. Okay? Roughly. 2.83. So if I do -3 plus 2 roots of 2, I'm really close to the x-axis. You should understand that. And I'm almost falling 3 units, so I should be really close to -6. Really, really close. And there's your 6 points, kids. There is your ellipse. So this one, I personally think its main tediousness was here. That's intimidating to a lot of kids. And if I was 16 and spent most of my life asking a calculator about numbers, it would intimidate the living crap out of me. Now, this isn't analyze, which means you're supposed to graph. I am not going to graph, but you are supposed to graph. It's a complete the square problem is what it is. Complete the square on it. So what we're going to do is we're going to get our x's together. 4x squared minus 8x. We're going to get our y's together. Plus y squared plus 4y. And notice I'm leaving gaps. It's kind of a big deal. And we're going to put this constant on the other side. Now I'm going to complete, actually, I almost messed up. This one's going to be a little rough. This is a problem. This is a big, big, big problem. That can't be there. Can't. And it's going to create another problem too. It really is. But I'll fix that. I'll have to fix it as we go. I got to divide that 4 out. Everything gets divided by 4. Everything. X squared minus 2x. Y squared over 4 plus y equals negative 1. I'm going to complete the square on this piece. And then I'm going to have to do some more manipulation to complete the square on this piece. So it's going to be kind of a pain in the butt. But to complete the square on this piece, I take half of a negative 2. Half of a negative 2 is a negative 1. I square it, and I add 1 to both sides. I don't have to add it over here with y, because I already added it to the left-hand side. So I better add it to the right-hand side. Now this piece is perfect. It factors. It's x minus 1 squared plus y squared over 4 plus y equals 0. Now, you cannot complete the square on this piece because the deal is the leading coefficient on completing the square is 1. So to fix that, I got to attack this 4. So what I have to do is I have to multiply every single term by 4 to make this a 1y squared. This is why I said it was kind of a pain in the butt. So I 4'd this piece, and I'm going to 4 both of these pieces. That's going to make that 1y squared. That's going to make that 4y. Thankfully, 0 times 4 is still 0. Now I can complete the square right here. And I'm not writing it down, but I'm taking half of 4. That's 2. 2 squared is 4. And I'm adding it to both sides. So now this piece factors. It's y plus 2 squared. And it equals 4. And you're really close to being in your proper form. To get into your proper form, this guy is supposed to be a 1. So we divide everything by 4. And things are starting to work out. That cancels. Becomes a 1. Normally we don't write those because they're understood, but we're talking about a form of how to graph, so we have to do it. Stays a 4 there. Becomes a 1 there. And now it is something that you can actually graph if you're paying attention and you're using your notes like you should do. There's a little side thing in your notes. You know, a lot of kids, they think that planets orbit the stars in a circular manner. They don't. You don't ever study gravity in high school, and most of you ever won't. But gravity kind of makes things function as a cone. The sun basically functions as the bottom of the cone, and planets literally fall towards the sun as they revolve around. Now, they're moving so fast that they stay at more or less the same level, but they do dip a little bit. And they're elliptical. Because of this, they get pulled in and they accelerate, and they pull themselves back out of the cone. Because of this, the orbits are not purely circular, they're elliptical. I don't remember the exact numbers, but it seems like the Earth's orbit is something like 99.7% circular. And that's what they tell you, percent circular, meaning it's really close to being a circle, but it's technically an ellipse. Because the Earth does get 8 or 9 million miles closer to the sun at points in its orbit. You would think that would be winter, but it's not. That actually happens for our summer. Winter and summer are about whether you're in the northern hemisphere or the southern hemisphere. It has nothing to do with distance to the sun, actually. Some degree, yes, but most part, no. That's tilt of the Earth. but I don't teach astronomy. So here's your last problem. This is about the Whispering Gallery in the Museum of Science and Industry in Chicago. And what it is there's a large elliptical, sorry, no, it is an ellipse. There's a large room shaped like an ellipse. So I'm going to draw an ellipse. I'm going to go ahead and center it and make it major x-axis just because it'll be easier on me. But there's a place over here by the wall and there's a place over here by the wall. And the deal is that you can whisper right here, and because of the properties of the way the room is shaped, because the ceiling is also an ellipse, you can hear it over here. But anywhere else, you can't hear it. Now it has to be quiet in there, otherwise everybody else will drown it out. But you can only hear that whisper here and here on other sides of the room. Now they tell us some stuff about this room. It's 47.3 feet long. So I take that 47.3, I divide it by 2, and what do I get here? 23.65. That gives me vertices of this room. I have a vertex at 23.650, and I have a vertex back here at negative 23.650. That gives me some major axes, okay? And it gives me the letter A. The distance from the center of the room to the foci is 20.3 feet. So again, I take my 20.3 and I cut it in half, and I get 10.15. Well, that gives me coordinates of the foci, 10.150 and negative 10.150. What letter of the alphabet did that give you? It gave you C for foci. And we're supposed to write an equation for this thing. All we have left to do is find B. That's really all you have left to do. So we'll set up our equation. B squared is A squared minus C squared. I'll have to use a calculator for this one because I'm not very good at squaring decimals. Hopefully I found the lengths properly. I think I did. 23.65 squared minus 10.15 squared. .65 squared minus 10.15 squared is that guy. Remember, that's equal to B squared. I take the square root, and I get 21.36. That's your B value. That is a major axis, or sorry, minor axis in this case. 21 point, we'll just say 36, because I carried these out 2 decimal places. Okay? So that would be 0, 21.36, and 0, comma, negative 21.36. Now, as far as the actual equation, well, we just plug everything in. Since the x-axis was the long axis, we have x squared over 23.65 squared. And don't square that number. That makes it look uglier. Like, type in your calculator. It's an uglier number. You just leave it 23.65 squared. You know, when numbers get ugly, leave them as pretty as you can leave them. We're doing ellipses today. We're doing something else tomorrow, and my mind is partially there. So I was almost about to put a y. Y here is at 21.36. And it's got to be squared, and we still equal 1. And that's it. See you guys Friday. Hopefully, if you don't get the Rona. Hopefully you don't.